Okay, this is going to be the last piece. I'll take you through a structural, just to show you how you put the structural stuff in. Hopefully by now you've done this. I'm not looking for a lot, I'm just looking for the fact that you're going to see this as a tool, especially if you're doing bridges. You might want to model those bridges in this. So you're required to do a structural, a load or two on your model. That's so you can figure out, in fact, how to get things to be in contact, how to use degrees of freedom and constraints. So I'm just going to open up my assembly here, take you through very quickly, extremely quickly, how to go about going through the environment of a stress analysis, in the hope that eventually some of you may get into the other great tools here like the movies and whatever else, but things to do, I'm sure. You're going to create a simulation. You need to have some constraints. The easiest thing in this case, for the most part, you want to put you have a pin constraint, you put a hole through something, it makes it pretty easy. I'm just going to go ahead and use a fixed constraint right there on that edge. So I fixed the constraint there. I turn my model around, fix my constraint right there. I'm going to put a fixed constraint there. You've now got two fixed constraints. Now you just need to put some loads on. And I will point out eventually it's going to be actually the best thing to use is going to be a remote force. But for now I'm going to go ahead and just put a force. And I'm going to use the vector components so you can learn to keep track of where your forces are going. There is some thread to back to what you're doing in other parts of other courses. 1 minus 1,000, in other words, one kip going down, the unit force, we're going to make this going down. We're going to give it a location, and the location gets very odd. And if you do it there, right, it's actually going to be not bad. If we go ahead and make that the minus 1,000, minus 1,000 pound. See, all of a sudden, it wants to know pound force, and I'll just leave that as it is. You see it's calculated the magnitude there. It's okay there, and so that's going to have some sort of we'll see how it does in terms of torquing this thing out. I'm going to go ahead and add one more so you see a torque over here on the other side. We'll go ahead and add, again, not how this is designed, but if you're looking now, we can go ahead and add another load, a force. In this case we will use vector components. Again, it will be minus 1,000 pound force. See, units do make a difference, and I'll make this 1,000 in the Y. I'm going to select my spot, and somehow it wants to find a direction, so we actually we want this to be a minus here. We still have our minus 1,000. So now we have essentially some sort of torque going around. We might go ahead and we could actually put a torque coming back the other direction. We'll just leave that at that. Hit OK here. So you have now on this, you have a couple of constraints, boundary conditions if you would, and a couple of forces. You then hit simulate and run. The frame generator actually applied the metal based on the frame we had. So one thing that you need to make sure with yours is that you assign a metal material to it, you assign constraints, you assign contacts, right, and then you assign loads. The reports or just the model itself and the summary is all I need. I just need to know that you can go in and start learning how to do this so that you can also truth it in some mathematical way. So in this case we have reactions. Eventually our reactions, if we look at this, should be, our two contacts should have reactions totaling on the way up of around 2,000. So we'll see whether that's the case. So if you go to the contacts here and you go to the constraints. You can go to fixed constraint, right click, and look at the reaction forces. And if you notice here in the Y, the reaction force is 744 pounds in the Y. I'm sorry, 891 in the Y. In the Z, on that one, you have a reaction moment as well. You see that there. And I'll do the same thing for fixed constraint here. You see that. So in effect, our reaction force should be equal to 2,000 pounds in the Z direction. And the sum of the forces in the X and the Y should also be equal to 0 when you add them up with this. So that's how you go about working, and then you notice the model starts to fall away. So a lot of this, basically, one of the things you're very much interested in is displacement, or look at results. We can go to the displacement in just the Z direction. We can right click activate, and you start to see how things change one way or the other in this model. So there's a report here. You can kind of go ahead and change what comes out of it. Typical kind of programming stuff, stimulations, what's coming, the results, constraints, sending out a report, lots of different stuff. You do not need to print it all, but you can submit that report to prove that you've gone and done some analysis on your structure. I would really hope and expect that many of you will want to then resubmit what you do on your bridge with Greg. I think that would be useful. It would be useful in an interview. It would be useful in tying some things together. And the modeling of it, you'll know, takes a lot less time in CAD than it's taken you to go about and doing it in your by hand. The kind of the scale model you've done. So you see it generating the report all the way through, and it comes up in an HTML, not unlike pretty extensive report. Don't print it. Just figure out a way to zip it up or show it to me on your computer. It's a lot of paper. Good stuff. You might pull some things out and put a summary. Some good information here that we've been looking at before. All comes out in the report. All right, that's the last piece of this. I'm going to, again, one more time, go and just show you then I'm going to finish the stress analysis. I'm going to go into the drawing, the IDW file, and show you then, in fact, in the IDW file, you have some ability here very easily to go to the annotate tools and to do things like dimensioning. And this is where, in fact, many of us in AutoCAD just don't spend too much time on the dimensioning because of this here. This dimension, we're going to go grab the dimension here. You see it, to grab it up, hit OK. You can go on to the next one, get close there, hit OK. Go to the next one, hit OK. And if you remember, mine was in inches. This is dimensioning now, I think, in feet. So you need to know, double check how things are going. I don't know that I necessarily ever scaled it up 12 times. So see, you have a little bit of an overlap in that dimension. We can go ahead and, let's see, dimension. If you grab a top there, it should hopefully find that height that you've got out there. So that you start to see how great the dimensioning is. You start to see how easy it is to bring in other views. This here is a section. If you notice there, you can bring in a section view. I'll bring in one more while we're doing it. Very much akin to place a view here. You can do a section view. Go to there, show it a line. Right click, continue. Hit OK. It's going to place a section view right there. So if you go ahead, right click and delete, takes the section view with it. So all that's good stuff. Those are the 2 submittals. Please try to get them in this week. Total time to do that, even start to finish, shouldn't be more than half an hour, but most of it you got done. Thanks for listening.